wonderful intro session. So, really excited to share my knowledge across the tech world actually. So, this will be my first session with Pune Tech Community. So, thank you very much to all the organizers, Nandeep, Smita, Siddharth, and Kunj. So, I'm really thankful to all of you and to all the participants. Welcome to the Demystifying the Cosmos TV session. My name is Arun, and I have around 15 years of experience in the IT industry. And so, right now, currently, I am, the Azure lead consultant or Azure consultant with Atos India. Okay, so I am right now. I'm actually certified in Cosmos DB. So that is my latest, certification. And as you can see, these are the I really found the Cosmos DB to be one of those interesting databases that I have come across in my experience. So I really wanted to actually share with you the knowledge of what exactly is Cosmos DB and where you can use Cosmos DB. Okay. So as part of this session, I will be covering the Cosmos DB introduction, and also I'll be talking about the benefits of using Cosmos DB in your day-to-day life or in your applications. Yep. And third one will be the APIs supported by Cosmos DB. So there are multiple APIs that you could, basically extend using Cosmos DB, and you could simply go ahead and use Cosmos DB as your database backend. Okay, so I'll show you how exactly we do that. Okay. So the fourth one will be basically Cosmos DB SDK in Python. So this will just be a very small demo of how we can actually create a Cosmos DB container and database in the Azure environment through Python code. Okay. So after that, I'll take you to the Azure portal where I'll be creating an Azure Cosmos DB resource, and I will be creating an account, creating a database, creating a container, and I'll be adding few values or few entries within the database, and I'll show you how we can query those entries. Okay, and to end with, I'll talk about indexing and partitioning. Okay, so how indexing and partitioning will help us in optimizing Cosmos DB performance. Okay. So with that, we'll start off with our session. So what is Cosmos DB? So Cosmos DB is actually a database as a solution or a PaaS solution, uh, which stands for Platform as a Service. Okay, so it's a database that is provided by Microsoft in the Azure environment. Okay, where you can simply use that service to store your data and connect your application. Okay. So since this is actually a PaaS environment, you don't really have to worry about the underlying hardware. So you don't have to worry about the storage, you don't have to worry about your scaling, or you don't have to worry about your processors, vCores, or you don't have to worry about any of those replication part or maintenance part. Okay, so everything is handled by Microsoft. So any patches or any security being any security related features that are being released to Cosmos DB, all those will be made available to you by Microsoft. So all you have to worry about is your data, okay, and your application. So rest everything Microsoft will take care for you. So that is the reason why it is actually a PaaS or a DBaaS solution, which means database as a solution. So this is Cosmos DB is actually a NoSQL database, So when you say NoSQL database, it doesn't follow the usual, row and table storage format. Okay, just like like your say Oracle PL SQL or the normal MS SQL server. So you don't have that row and database, funda here. Okay, so all the data are stored in the form of documents. So when I say documents, they are stored in the form of JSON format, which is nothing but your key value pairs. Okay, so you for every value you have a key and you have a specific value stored across that key in the database. So that is what they call as JSON format. And so each item or each item stored inside the Cosmos DB, they are referred to as individual documents. Okay. Now, this is actually an open source framework. It's based on open source framework, so you could basically use this. I mean, there is no licensing involved yet, so you don't have to worry about buying licenses, right? So it is available free of Microsoft has made it available free of cost, and all you have to do is use that existing source code, and you can very well build another database upon it. Okay, so just like your Android, this is an open source database, and you could very well use this database to create your own. You could add your own wrapper to it, and you could basically build another database product for your own company requirements. So since this doesn't involve any licensing cost, it is actually cheaper, way more cheaper to use Cosmos DB. Or if you want to actually get into a Cosmos DB environment, it's easier and it's cheaper to start using Cosmos DB. Okay, so to basically move your environment from your on-prem or your existing environment, you have several migration tools, Azure migration tools provided by Microsoft themselves, and you could basically use those migration tools or the tools provided by Microsoft to basically migrate your data from your on-prem or from another database into Cosmos DB. Okay. So this is all with respect to Cosmos DB. Okay. So the next question will be, why do I have to use Cosmos DB? Okay. So when I already have a database that is working as intended, why do I have to worry about Cosmos DB? Okay. Now, the first thing the first key benefit that you realize with Cosmos DB is that since it's a PaaS solution, okay, all the underlying softwares are managed by Microsoft. So your overhead basically reduces manifold. Okay, you don't have to worry about buying servers, or you don't have to worry about buying licenses. You don't have to worry about your physical data centers or anything like that. Okay, anything that is related to capital cost, that gets eliminated totally. Okay, so you begin with a large amount of savings, okay, when you start using Cosmos DB. Okay, so since Microsoft actually takes care of all the underlying hardwares, they also take care of all the availability stuff. Okay, so you say replication, or you say scalability or availability. You talk about any of those 24 bar 7 availability stuff. Microsoft ensures that your application is available 24 bar 7, okay, without any glitch. Okay, and even in case of any issues, Microsoft will ensure like the switching happens seamlessly, and you wouldn't probably notice that there are issues within the environment itself. Okay. So that is how easy or how safe it is to use Cosmos DB. Okay, so you don't have to worry about scalings. You don't have to worry about availabilities. You don't have to worry about replications or how it happens, where it happens. You don't have to worry about it. Cosmos DB takes care of everything, and it is also compliant with all the regional, compliance requirements. For example, in India, there is a requirement from RBI that any card number data or Indian customer data should only reside within the servers, servers that are physically situated or present physically or virtually present within India itself. Okay, so I cannot have another server in Europe that is basically replicating all the Indian financial data. Okay, so Cosmos DB ensures that such requirements are compliant, okay, without any compromise. So there is no question of you violating any of these requirements. Okay, so when you have a server within India, the replication is going to happen only within the local regions, or you say uh, zonal region or ZRS. Okay, so if I have a server in South India, yeah, the replication is going to happen only to the Central India's zone. So that is how Cosmos DB ensures like all the compliance requirements are met without any compromise. Okay. So as I mentioned in my previous part, this is an open source, software. Okay. So you basically have all the source codes available over the internet. Okay. So anybody can just go over there, go through the documentation, understand what exactly the implementation is or how the implementation is done with, and you could adopt that particular source code, or you could take that particular source code and you could work on the source code. You can uh, how do I say, you could basically make improvements to the source code, or you could add your own wrappers over it, or you could basically do your own customizations. Okay, so that is how Cosmos DB ensures that your cloud adoption is much faster. Okay, so since it is open source, everything is available over internet, over the internet. The documentation is available, it is transparent, so it's easier for you to adopt that framework, the existing framework, and you could basically make improvements to it, or you can customize it to it your own requirements. Okay, so that is how the adoption is being made faster with respect to Cosmos DB. Now, since this is a part of the Azure environment itself, or the Azure infrastructure, you have the option of integrating this service with all other existing Azure services. Okay, for instance, you have the functionality called Cosmos DB trigger within Azure Functions. Okay, so what it basically does is, if I am going to make any changes to the existing documents in the Cosmos DB environment or Cosmos DB document, so this will trigger an Azure function. Okay, uh, so you could basically have a serverless Azure function written for it, or you could have a trigger for it, and that trigger will basically, uh, read all the updated values within the Cosmos DB environment, and act upon those values and basically perform actions over it. Okay, so that is one example of how it is, how Cosmos DB is basically integrated with the other services. Okay, and you could also have a pipeline setup with respect to the Azure Data Factory. Okay, so you could actually have an ingress or egress pipelines. Okay, so basically say input or output in a much more simple word. Okay, so you could have it as an input source, or you could basically they call it as sync or the output source. You could basically attach or link Cosmos DB with ADF to have it as an input or a sync source. So that is just an example of how Cosmos DB is integrated with the other Azure services. Okay. So as I mentioned in my previous slide, you have multiple APIs provided by Cosmos DB. Okay. So you have MongoDB API, you have Cassandra API, you have Graph APIs. Okay. You have NoSQL, that's the core NoSQL APIs. Okay, so there are 6 different APIs provided by Cosmos DB. So basically, it refers to the types of databases that are currently available. So you have graph-based database, you have columnar database, okay, you have row and table database, you have key value pair database, okay, and you have NoSQL based databases available over the market. So Cosmos DB basically ensures that it provides APIs, right, of all these databases, so that you can actually move from existing environment to the Cosmos DB environment without having to make changes to your data layer. All you have to do is basically extend one of these APIs. Okay, use the connection string and your keys, and you are good to go. You are basically like connecting your application to the backend. So all these APIs, right? It makes your life very simple, and if it actually enables you to move faster or adapt cloud faster or Azure faster with respect to your on-prem application. So if you want to move to cloud, Cosmos DB is one of those applications which will provide your API requirements, right? So you could, so that is one of the key benefits for Cosmos DB. So these are the key benefits of using Cosmos DB. So the next one is basically the API supported, right? So API for NoSQL, which is the native Cosmos DB, and this is the primary database, the native database for Cosmos DB. So the rest of the APIs, right? MongoDB, Cassandra, PostgreSQL, Gremlin, and tables. So they are all basically mirrored framework. Okay, so when I say mirrored framework, right, it basically mirrors the existing functionality of these databases. So you wouldn't basically experience any of those differences with respect to your, say, when you use your API for MongoDB, you would probably not recognize any differences with respect to the MongoDB being used in on-prem. Okay, so all these APIs, just mirrors the existing environment. Okay, and you will be able to move your applications or adapt to cloud faster uh, by just concentrating on your setting up or your you know uh, on setting up these services rather than working on your code level activities. Okay, so there won't be very minimal. There will be very minimal code level changes where you will probably have to change your connection strings and your private keys. Okay, so these are the APIs that are available. So I'll probably show you that as well while I fire the queries. Okay, so right now, if you actually see, you have a separate service for PostgreSQL. Okay, within Azure. So Azure for PostgreSQL, you will have Azure for SQL servers. It's also this PostgreSQL will probably, my hunch is this PostgreSQL will move out of Cosmos DB once the Azure Azure SQL for Postgre, I mean Azure service for PostgreSQL is made generally available. Okay, so I mean that's still in pipeline. I mean it's still in preview. So anyways, currently you can use this API for PostgreSQL for your you know database requirement. So now, in this session, I will be, concentrating more on the native Cosmos DB. Okay, so when I say native Cosmos DB, it is based on NoSQL. Okay, NoSQL, and the data is actually stored in the form of documents. When I say documents, it's again JSON format. Okay, so since this is the native Cosmos DB, any changes or any updates to Cosmos DB is first made available to the native NoSQL API. Okay, so once the native NoSQL API is stable, it is then made available to the other APIs within the Cosmos DB environment. Okay, so this is considered as the mother of all the, or it's actually the first entry point for Cosmos DB for any updates. Okay, and then it is percolated to the other databases. Right. So as I said, it basically stores in document format. Each of the items within NoSQL format or NoSQL database is stored in document format, and you could still use your normal SQL syntax, right, to query the database, which I will actually show you in a demo. Okay. So Microsoft actually recommends this option if you are migrating from Hadoop environment or a HBase environment, Oracle environment, or a DynamoDB, which is the AWS environment, right? So if you are moving from those environments, Microsoft basically recommends you to move over to the NoSQL API because it is actually easier to migrate those environment or those databases into the Cosmos DB NoSQL API. Okay. Now, so now I'll probably start with this demo, and I'll quickly show you how to go about interacting with the Cosmos DB API. Okay, to do that, you would basically first need an account. Okay, so I mean, if anybody has worked with the storage, right, storages, any storage, you would first need storage account. Okay, so only within that account you could basically have your containers where you will store your blobs or your any images, videos, files, whatever. Okay, so just like that, you would basically need to create an account. Okay, so I'm creating an account. So these are the APIs that you could see, right? So this is for NoSQL, this is for Postgre, this is for MongoDB. So this is how you actually create these services. So today I'm going to show you how to do SQL. Okay, so the first thing that you require to create any service within Azure, okay, is your subscription. Okay, it can be a free subscription, it can be pay as you go subscription, it can be MSTS subscription, it can be enterprise subscription, any sort of subscription, but you need to have some form of subscription to create an account or create a service within Azure environment. Okay, so I have I've chosen the MSDM subscription, and I already have a test resource group. Okay, a resource group created within my environment. So that's test RG. Okay. Now the next thing that you would need is the account name. Okay. So I'm just going to create uh, something like cars database account. Yeah, it's available. Okay, so let it be in US. Okay, now if you see here, you actually see two different options: provision throughput and serverless. So what's the difference? So provision throughput is okay. Before I talk about provision throughput, you will probably need to understand what's a throughput. Throughput is measured in terms of RUs or request units. Okay, so what is request units? Request units is nothing but the combination of memory, IOPS, okay, and CPU. Okay, that is required to basically perform a transaction. So it can be a read transaction, it can be a retrieve transaction, whatever. Okay. So how much memory, IOPS and CPU is being consumed, okay, to retrieve a 1 KB or perform a 1 KB document or data. Okay, so this is actually called as one request unit. Okay, so all these throughputs are measured in terms of request units or RUs. Okay, now coming to the difference. Now, what is provision throughput? Provision throughput is nothing but you are manually setting up the maximum number of throughputs that are allowed to be performed within this account. Okay, so for example, if I say 4,000 RUs, okay, which means I can basically consume 4,000 units of memories, IOPS and CPU, okay, for retrieving this, for retrieving data from this account. So this is the maximum limit. Okay, if it goes beyond this limit, the request is going to get timed out. Okay, there is no way I can actually exceed this value in case of provision throughput. Okay, now what is serverless? Serverless is nothing but you are not specifying this particular value, or you are basically saying I'm setting this value here. Okay, I'm setting 10,000 RUs. Okay, now I can actually move or I can exit this amount for some on some particular days. Okay, for example, I actually run a e-commerce website. Okay, and you always have these Diwali sale, New Year sale, Black Friday sale, whatever. You have different kind of sale days, right? So on those particular days, I am going to see peak traffic in my application. So I am definitely going to hit the ceiling. Okay, but I don't want any of these transactions to time out. To be successful. Okay, so what I'm actually effectively saying is I don't care how much ever I get, I want to ensure like all those transactions are processed. Okay, so in serverless, Microsoft takes care of the scaling part. So if any of these, or if at any point in time my peak traffic hits more than 1,000 request units, it is going to actually scale my application, or it is going to basically create another physical partition. Okay, and it will again give me 100 RU, 1,000 RUs. Okay, so this is how the serverless works. Okay, so your it will be seamless. The scaling will be seamless, and your application will be available all the time, or your connection is not going to get affected. Okay, so to know all these, you will basically need to understand your application throughput, or what is, or you should excuse me, you should be able to gauge the application requests that are going in and out of your databases. Only then you will be able to do the provision throughput. Okay, otherwise you will probably set up some lesser values and your transactions are going to get timed out. Okay, so now since I'm going for provision throughput, Microsoft is actually giving me initial 1,000 RUs and 25 GB of storage for free. Okay, which means my first 1,000 request units is not going to cost me any money, right? So I'm going to use this, okay, just to get these 1,000 RUs, because my I mean, this is going to be a very small demo. So this will be this is just a small one or two request units. So I'm just using this RUs, free RUs, and I'm going to created now. Created, and it will take at least probably around 2 minutes for this account to get created. Okay, so we'll just wait for the account to be created. Okay, so let this be in progress. In the meanwhile, I'll talk about the libraries that are required. Okay, now to to interact with Cosmos DB, you would need a library called Azure.Cosmos. Okay, so you will need this library. Okay, so basically you go to command prompt, you simply say pip install Azure.Cosmos. Okay, so I already have this, so that is the reason why it says already satisfied. If this version is not available, it is going to download for you from the Python site, and it's going to install it for you. Okay, and within this package, I am going to use a couple of classes called Cosmos Client and Partition Key. Okay, so these are the two classes that I'll be using for this particular demo. Okay, now see if this has come. Yeah, okay, this is still in place. Now let's talk about the architecture. Okay, so how does the architecture look like? So the architecture is pretty simple. I'll use a box area. So you have this account here. Okay, this will be the account, and within which you will have a database, and inside this database you will have the containers. Okay, so this container is actually used to store all your document. Okay, and inside this container you will have your items, item 1, item 2, item 3, so something like that. So all your items will be stored within this container. So we are going to use this architecture to create this to interact with the Cosmos DB client. Okay, to do that, first thing you need is basically your URL, your endpoint, and your primary key. Okay, so I'm just going to store this uh, let's say endpoint. Okay, and your key. Now, tip number one, you are not supposed to actually store these values in your code. Okay, so these are all PII or confidential information which needs to be stored within the uh, key vault. Okay, and from there you should be accessing the key values. So since this is just a demo session, I'm just storing it here. Okay, so in this example, I'm going to create a database called Hyundai. Okay, and sorry, and I'm going to create a container called cars. Okay, so I'm going to create a database of all the cars that are currently manufactured and sold by Hyundai. Okay, so I got this information. So if you look at this, first thing is we'll need to create this account. Okay, to create this account, what you will need is basically a client object. Okay, now client object is obtained using this Cosmos client. Okay, now I'm going to use this endpoint here. So URL equal to uh, endpoint. Okay, and credential equal to, okay, and using this client, I am going to create a database. Since the database resides within the account, I'm going to create a database object. Okay? Now client dot create database if not exist. Okay, so this is the method that is going to help us create this database. Okay, so I'm passing this database name. Now, let's just run. I'll store this somewhere. I'll just give it as index text. Now, let's just run it and see if this is okay. I'll print another one. Database. So what I'm essentially doing here is I'm going to print the database name that is actually created. Let's see. Let's just run it and see. Um, okay, I gave the wrong name. Smart. Click smart. Let's just run it. Okay, so if you see here, we have received a database name called Hyundai. Okay, so let's just go to here. Um, so you have something called Database Explorer where you could actually view this database. So this is okay, right? Now this is just a container or a database. So I'll need to create a container within it. So I'm using before I create a container, I will actually have to create the partition key. Okay, so partition key. Uh, so not equal. I'm giving it as let's go ahead and create the container. Equal to database. Now create container if not this. Okay. Now, what are the values that I need to pass? First thing is I will need to pass the container name, and secondly, I will need to pass the partition key equal to the path. Okay, and I will need to mention the throughput value. Okay, throughput is nothing but I'm restricting the number of input and number of request units that I can use, or basically this container can handle. Okay, now I'm going to print this container name that has been created. Let's see. Container. Let's just run it. Okay, cool. So now we have a container called cars. Okay, let me. So it is, if you can see here, we have a cars container. So now, but we don't have any items here. Okay, so let's just get the inputs. Okay, I have actually saved some time. I have created these inputs. Okay, let's just go ahead and use them. Okay. Now these are the so now the first thing is container dot create item is the method to basically create this item. Okay, now input one. Let me quickly go ahead and copy it. 2, 3, 4, 5, 6. 6. Now let's just quickly insert these items. Okay. Let's see if it gets inserted. Right. Let's go to our database here. Click on items, just refresh it, and there you go. So you have all these entries here. If you see here, you have the types of uh, items, or six number of items that are currently inserted into this document. Now, how do I basically retrieve this document? So, I mean, just to okay, let me create another variable. Okay, so I'll just show you how do we retrieve items from the Cosmos DB database. So we have container dot read item. Okay. Now I'll just pass this partition key. Right? Let's just see what we get when we actually search for partition key. Okay, it has SUV. Now, we don't need these. I'll go ahead and comment that. Okay. Now let's just run this and see what values we get. Okay. Okay. I'll see ID. Now what is the ID? I need 102, 102, right? Yeah, 102. Okay. Comma. Okay. Now in, let's just print this products and see. Products. No, 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 no. Okay. Okay. This is product. Okay. And give a okay, cool. So if you see here, you get this ID, right? Okay. Now, this is the value that I have stored. Okay. So if you see here, it's actually 102 SUV Creta two-wheel drive. Yeah. So it is. So we are basically communicated with the Cosmos DB client. Okay. But there are. I would simply urge you to go to azure.cosmos.db. Okay. So if you go here, you will have an excellent documentation provided by Microsoft. Okay, and I would really urge you to go through these reference document. So it will they also have the source codes here. Okay, so you click on the Azure Cosmos. Okay, and I've used containers, right? Let me just go to container and show you. Okay, so these are the implementation. Okay, so if you see here, what are the values that, or what are the functions that are available? Right. So here, if you see, it says read item, right? And you already have seen read item here, right? And you have observed. Okay, you have read all items, which will basically get all the documents that are stored within the database. Right, you have query items change field, which is uh, it will only look for the items that have been updated within the Cosmos DB environment. Right. So there are multiple methods that are available here. So I would urge each and every one of you to go through this documentation to understand the capabilities of this particular database, so that you could you could basically use these methods to help in your cloud journey. Okay. Now the next part is, so I actually showed you how we go about creating the database account. Okay, so I'll now show you how do we go about querying the database. Okay, now I have this family, so I just to save time, I have okay, only 15 minutes left now. Okay. Now I have created this container. Let me go here. Okay. Now, so I already have a family tree here. Okay. And I have created or I have inserted couple of entries here. Okay. So this will basically show me about the Sharma family. There are two family details, Sharma and Mehta, right? I have created them. I have inserted them. So this is just a family tree of those two families here. Now I want to actually query them. Okay, so simply family F. Okay, so this is how easy it is to query the database. So if you are familiar with SQL, you know that this is the SQL. Uh, how do I say SQL syntax, right? Okay, now I actually talked about the throughputs here. Okay, if you see here, we go here. It will you actually see this 4000, right? So that is the maximum RU that I can use, and this particular container can only accept 400 RUs. Okay, so I cannot go beyond 400 or I cannot go beyond 4000 for in fact this particular for the entire database. So I can have 25 different containers within an account. Okay, each document can be of 2 GB size, and each physical partition or physical storage will be of 50 GB size. Okay, and if you are going to actually go beyond 50 GB, no problems. You can have unlimited storage. Microsoft is going to give you the storage for you, but again you'll have to pay for the storage, right? Okay, so now coming back to this here. Okay. This is the query, right? Now I want to get only the family ID here. Okay, so how do I go about doing that? So I have this alias here, so I will simply say f dot f dot id. So if I run this query, voila. So you will get the family ID name here, right? Okay. Now how do I filter? Basically, I want the names uh, of people or the family details or family ID who are residing within say Mumbai, right? Within Mumbai city, right? So I have this Mumbai here. Okay, so I go to this query. All I have to do is select f.id from family f, where uh, f dot address dot city, what's sorry, query items here, what's the okay, city is this, city equal to 5. Now let's run this, let's see what happens, right? So I have this family, right, Mehta family, that is residing in uh, Mumbai. Now there is a concept that I would like to introduce you. I mean, new concept. Okay, so it is called joining. So in a SQL, you would have come across joining where you will join two different database tables. Okay, but here in Cosmos DB, joining works in a different way. Okay, now I have these family tree where you have these children, right? So I have couple of children here whose name is Chaya and Kishan. Right? So they belong to this Mehta family, and one of them is male and the other one is female. Now I want to get the family name or the first name of children, okay, of all children who reside in Mumbai city. Right? I'll just use this query, okay, to work on it. Let's clear this out. Okay. Now, so this is family F. Right? Here you will have to mention join C in uh, children, right? Yeah. What's the name? Children here, right? Children. F where C dot, I'm going to basically this is F dot, right, sorry, F dot address dot C. I'm going to give the get the first name, right? So C dot, this one is first name. What I'm actually doing here is I'm going to get the first name of all the children that are residing in Mumbai. Let's see if this runs. So this is, I should have actually used the left. Now what? C dot first name family join C E children. Okay, one by one, please. Should have been mm, yes. Maybe the name is wrong. Okay. First name, right? Okay. Okay, so you have these two children, okay, that who reside in Mumbai. So this is how you actually use join within Cosmos DB. Okay, so this join here is basically with the children record here. You are joining family record with the children record, and you are basically using the children record to print the values here. Okay, so this is how joining works. Okay, so just like as I said, it always Cosmos DB supports SQL syntax, right? So you have other other functions, right? So you have aggregates, you have user defined functions. It basically supports everything here. Okay, so since I'm running out of time, let me quickly copy this. I actually wanted to show you. So this is nothing but I am creating array objects here. Let's just run this. So what I'm doing here is I'm creating an array of children here. Okay, so that reside in Mumbai. Okay? So this is how you go about creating arrays. Now I don't JSON format. So you use something called as iterators, right? So for iterators, basically you are using something like this. Okay. Select. Okay. Now, this let's see. Okay. And we got children. Doing this count. It's this and simple. Okay. So what I have done is basically I have iterated through each of those documents, and I have retrieved the first name of all the children, irrespective of whether irrespective of which family they belong to. Do the count, just like I said, it basically supports aggregates. So you do count here, it will give you the. Now, this is how you actually go about querying within database. Now, let me quickly come over to partition. Okay, so that is something that I really wanted to take here. Okay, this is called as partition key. Okay, so partition is nothing but you have it's like a logical separation of your storages. Okay, so for example, in this example, I had used something called as category name here. Okay, so category name is nothing but it's like hatchback or your sedans, and you have SUVs. So these are three types of body or three body types that Hyundai currently has within its portfolio. Right? It can have it can be sedan, it can be hatchback, it can be SUV. Okay, so basically for each of these partition, right, it is going to actually create a logical separation. Okay, so for example, all the SUVs will get stored under a particular logical partition. All the hatchbacks will get stored under a separate partition. Okay, so something like this, all the sedans will get stored under separate partition. So why would Cosmos DB do this? So the main reason to do this is like faster, retrieval, or lesser, request units involved in retrieving data. Okay, so each request units is money. So Cosmos DB uses this partition tool to basically, create smaller chunks of data, or basically divide large database into smaller chunks, so that it is easier for the code to retrieve data. So if I actually pass SUV, right? So I don't have to look into each of these logical partitions. So I'll just have to look into the individual SUV partition, individual sedan partition. Okay. So based on your query, it will only fetch data from those particular partitions. So which will save you on your request units. So that is the importance of partition key. So whenever you have a large database, do not forget to include partition key, and it is really important that you choose the correct partition key. Otherwise it will basically lead to hard partitions, or basically your storages will not be used effectively, and the storages will be skewed, or one of the logical partition will have all the data or most of the data. Few of those partitions will have lesser number of data, and it will not be effectively used. Okay, so that is the importance of partition key. Now let me come to this scale here. It's important. Now auto scaling, manual scaling, yeah, that's done. And what else should I actually want to show? Yeah, indexing policy. Now, this is something again an important concept. Okay, so you would have heard about indexing, right? So in database terms, indexing is nothing but whenever you insert a value or insert the data into the database will automatically create an index, so that next time you search for that data, it knows, the database knows what path needs to be taken to retrieve that data, so that it does not look at each and every partition available within the database to retrieve the data. And this indexing policies will result in faster retrieval of data. Okay, so when I talk about indexing policies, right, there are three types of policies. One is specific, okay, which is basically represented as question mark. So this will result in scalar value, which is when I say where clause. uh, so in the previous example I actually mentioned as city equal to Mumbai, right? So this is being specific. So I want only Mumbai based data. So this indexing will basically follow this path, okay, to Mumbai, all the way to the city where this city value is stored, and it is going to retrieve all the data related to Mumbai. Okay? So that is what scalar value is, and the next is your range. Okay, now if I actually say city in Mumbai, comma Delhi, right? Which means I am actually specifying a range here. So this is actually a while character, and it will retrieve values from both Mumbai as well as Delhi. Okay, so this is actually less efficient than the scalar one. So this has a higher preference over this. Okay, now third one is nothing but I mean these are the two types of values, and third one is array. Okay, array is nothing but the yeah, here it is. Let's go to this particular here. This is the array, so it will be stored in terms of zeros and one. Okay, it will be stored in zeros and one here. Okay. Now that is how Cosmos DB is going to retrieve this value. Okay. Now there is actually preference, or one has more preference than the other. Right. So for example here, now take this Hyundai family, right? Now, this one is much more easier. Let's take this ID. Let's take this family tree here. Okay. So I have this ID, last name, parents, right? So you will have a root here. Okay. Let me create in this. Okay. You will have a root box. You'll have the root here, and you will have three different, what are the values here. You're having ID, last name, parents, okay, children, and address. So you have five different uh, roots here. Okay, 1, 2, 3, 4, and 5. Okay, so here children will have, there are only one children here, right? So this will basically be termed as 0. Okay, I mean this is children, sorry, this is children here. C H, yeah, this is children box, and under this you will have the 0 index. Okay, so that 0 index basically has all these child values. Okay, now similarly you have ID here. Okay, and you have your first name here, like that. Okay, so etc etc. So you will actually have these indexes assigned to this. So when I actually say ID equal to Sharma family, so Cosmos DB will know that ID is present here, right? And I'll need to go to this particular path, right, to fetch the data. So that is how indexing works. So you will need to specify this path here, indexing path. Basically, you go here, go to this indexing path, and you specify ID space uh, start. Okay, so that's it, done. So this is basically you're saying you follow this path, you don't need to follow any other path here. Okay, so when I actually say when ID equal to this, it will make it easier for Azure Cosmos DB to retrieve the data faster. Okay? So that is the importance of this indexing policy. So you have preferences here. Specifics will always have higher priority. Okay. For example, I have this path here, right? Let me give this. I'll probably mention it as. Sorry. Let me mention it as. Um, this. So okay, so what is the difference here? So both are basically following the path here, right? ID path, but being specific will have higher specific or higher preference over range. Okay, so accordingly, use your indexing policies, okay, to ensure faster retrieval with lesser consumption. Okay, so this is the importance of indexing. Okay. So with this, I have actually come to an end of this session. Okay, so you would now be, comfortable, or basically, know the fundamentals of Cosmos DB. Okay, so this, please use this as a platform. When you go to the Cosmos DB documentation, you go through that. Microsoft has provided an excellent document where you could basically build on this particular Cosmos DB knowledge. Okay. So for any doubts or any clarifications, please do feel free to reach out to me on my you know, uh, LinkedIn account. So I'll share that as well to you. Okay. So yeah, this is my LinkedIn account. Okay, so please feel free to reach out to me for any IAS related or PAS related, Cosmos DB, you name it. Please reach out to me for anything, and I will definitely help clarify your queries. Okay. So with this, I conclude my session, and I would like to thank all of you for patiently listening to me. I know I've overshot my session, but thank you very much for patiently being on this call. And a special thanks to Smita, Nandeep, Kunj, uh, and Siddharth for all for providing me this opportunity. So thank you very much, and I end this session right now. Thank you.